Hi, I'm Bill Hitchcock. It is April 27th, 2020 when I'm recording this, and we're going to be working with some data to demonstrate some of Excel's regression techniques and features that we can put in. So I've got a workbook. It's got 3 sheets on it. I've got the adult males, their heights and weights. We've got some truck prices. We've got cricket chirps at the end here. The truck prices and cricket chirps are some smaller data sets. You can work on them yourselves, and that'll be part of that. But in the meantime, I've got a fairly large data set, and what I want to do is just kind of check a few things out, do some initial formatting, and see if we can get just some simple tests. So for my sequence or record number, if you want to call it, I'm going to hold my shift key, hit the end key, and down arrow. It looks like I've got 694 records. I can format those with a comma format, get rid of the 2 decimal places. That way, if I have over 1,000 records, I'll have a comma in there. Next, what I want to do is take a look at the height and the weight. I'm going to highlight all of those cells. So again, I'm holding my shift key and down arrow. And if you want to go a little bit farther, it won't hurt. We'll use again, comma format would work well here. It gives me 2 decimal places. I want to increase the decimal place a number of times, 5 or 6, whatever it might be. I think 6 is about as far as the data goes carried out to. So let's just do it to 6. Then I'm going to highlight my field names. So shift, right. Center those, boldface, wrap text. And you can decide about font size if you need to shrink down the font size. At this point, I don't think we need to. So, since I've got close to 700 records here, I just want to focus on maybe just do some experimenting, try it out with 10 records, see what happens. So I'm going to hit Control Home, and I'll save my work, and I'm going to make a copy of this sheet. So I'm going to come down to the Sheet tab, right-click, choose Move or Copy. I want to create a copy, and let's put it right in front of the truck prices, hit OK, and there's my new copy. So I'm going to rename this one, and I'll say, I don't know, let's right click on this, choose rename, and call it maybe first 10 records. So I'm going to take all my data, starting at record number 11, hold my shift key, first notice that I clicked on the row number 12, shift, end, and down. Then I'll right click on any one of those row numbers and just delete them. Hit Control Home, and I've got just my 10 records. All right, that's all I really kind of want to work with here. Next thing what I want to do is, just to make it a little bit easier to work with these numbers, I'm going to take them and round them off. So if we put in the rounded height and the rounded weight, I'm going to round those numbers off using the round function. So I point to the height, type in a comma. I want to round it off to the nearest integer, the nearest 0 decimals. And let's format that. And as I copy this to all these, I want to do it with both the heights and the weights. There it's rounded everything off to the nearest integer, and we can remove the decimals and just show you that. All right. So for instance, if you want to think of it this way, we've got a male who is 74, we'll assume that this is inches tall, and the weight is 242. We have another one that's 69, 162. If you wanted to find out exactly what it was as far as looking at these heights and weights, or I should say the heights in feet and inches, we could do a calculation. So we'll do the feet, and we'll put in inches, and let's just take the height in inches, divide it by 12, and if we format that, it tells me it's 6.17 feet. But again, we want to do this in inches and feet, so let's use the integer function on that. and it should give me the 6 feet. Let's copy this down. So here we've got one 5 feet 6 and so on. And then to get to the inches, what we can do is take the height and subtract off the feet times 12. And it should tell us how many inches are remaining. So here we've got somebody who is 5'9", 6'2", and so on. Here's somebody who's 5'10", 70 inches. That makes sense. And let's format all of those. We don't need decimal places, so let's get rid of that. This one looks a little bit odd as far as with the 6 and a dash, or 6 flat, you could call it if you want to. So if you want to change the format to just a plain number format, right-click on it, format those. Choose number, leave the decimals to 0. Let's try that. And that way you can see it 6-0 for our feet and inches. And we can shrink these columns up. Probably not that narrow. It's a little bit tight. There we go. So we've got that data in there as well. All right. Save your work. And again, you could, what I want you to try doing is apply some of these things to the full data set when we're all done. All right. Okay. Other things that I would probably want to do is I want to take a look at things like the minimum, the average, the maximum. So we can do equals min, and I want to get the minimum of that. I want to do the equal average for the height and the equal max, just to get a feel for how everything's working out. And we can copy those across. Now for the height, the feet and inches, what you might want to do is actually copy these formulas rather than doing minimum and maximums on it. And here, let me just widen out those columns quickly. Let's format things. Let's see, we've got those. Those are formatted just fine. But let's use the format that we had for here. And let's use the format that we had here. And the format that I had for my feet and inches. All right, notice for the minimum, we've got somebody that's listed as 5'0", 5 foot even. Well, that's not really true because there are no males that are just 5 feet. It took the minimum of the feet, 5 feet, and it took the minimum of the inches and kind of combined those two things. So what we should do is we'll copy this down to here, and we'll do the computation where we're looking at the minimum, and maximum of the minimum number of inches that somebody is, the maximum number of inches that they are. So that will give us kind of the correct results on something like this. If you want to test it out and make sure that you are getting the correct numbers, go ahead, format, or I should say, sort some of this data. So there's our shortest person, 5'3". Our tallest people, we've got 2 people that are 74 inches, and there we've got that. Let's see, if I sort by weight, we've got somebody who's 152 pounds. We've got somebody that's 242 pounds. So we've got that information here. And we can kind of work around with some of this data. All right, so that gives us just kind of a feel for where some of these people fit. All right, let's take our data now and let's sort it back in the original record or the order that we had. So 1 through 10. And I want to do is take a look at what's the relationship between somebody's height and weight. I would assume that as a person gets taller, most likely they're going to put on more weight just because there's more body mass to do something like that. So what we can do is we can highlight our fields, the height and weight, and we'll insert an XY plot. And there we can see, let's see, as the weight is, or I should say as the height is going up, it looks like the weight is also going up. You know, there seems to be some sort of a trend line here. So what we want to do is we want to, we can use Excel's features to add the trend line in there, but we also want to try to calculate this out ourselves and see how close we can come with it. So let me change my chart just slightly. And if I add a chart element onto it, I want to add an axis title. The horizontal is my height, if I can spell height in inches. And we'll add the primary vertical, weight in pounds. So we've got that. And the title, we can change that to maybe be height versus weight for these 10 records. All right, save this. Okay, first, for making our own prediction line, what I want to do is I'm going to take this dot right here. And if I mouse over it, it tells me that it is a point of 63 inches and 156 pounds. And it looks like that was our very, it looks like I've got my data sorted there, and it's showing me that first record. Right, then at the end, if I point to, you know, if I'm going to draw a line from here through as many of these as I can, I kind of want to go right in between here. So it's a matter of, all right, do you want to choose this dot? Do you want to choose this dot? Should I choose this dot, for instance? You know, take your best guess at what do you think that would make sense to draw a line through some of these. I'm just going to pull this one because, you know, it looks like a couple of the dots are going to fall below it. So I'm going to choose this one. This one is 74 inches and 213 pounds. So remember those numbers. That's what I want to work with. So we've got our equation for our prediction is going to use something that you learned probably back in high school, grade school, something like that. The equation for a straight line. So that's y equals mx plus b, where y is the dependent variable, in this case weight, x is my independent variable, in this case height, m is the slope, and b is where this is going to cross the y-axis, in other words the weight axis, if the height was 0. So let's figure out how we can do this. We're going to need some points. We need x1 and y1. I need x2 and y2. So my x1 is my independent variable, 63 inches. And we said where that crosses the dependent part is 156 pounds. And let me format these. My second point is x2, that was 74 inches, and 213. And again, you don't have to type in those numbers. You could always reference them up in your data set. So just say equals this cell, for instance. That would work out for you. Right, next step is to get the rise and the run. The rise is y2 minus y1. The run is x2 minus x1. So in other words, the difference between this spot here, 63, and this spot over here, 74, that's my run. The difference between 150 and, what was that, 213, that's how much it's rising. So if you think of it like on a roof or something like that, it's going up this far and it's going over that far. So it's a fairly, I don't know, low slope, if you will. All right, so y2 is 213 minus the 156. Gives me 57 pounds that it's changing. My x2 was 74 inches minus 63. So the height changed to almost a foot, 11 inches. The weight changed 57 pounds. And if you want to put in labels, all that would be useful. So my slope is the rise divided by the run. So it's equal to the 57 pounds divided by the 11 inches. It's going up 5.1818 repeating. So let's format that. 1 decimal would probably be even enough. Or if you want to do the 2 decimals, it doesn't hurt it. So for every inch that, this would be the pounds per inch. Let me try that again. Pounds per inch that our prediction is making. All right, next what I got to come up with is I want to figure out what B is. Right, so if you think about the math on this, I've got y equals mx plus b. If I would subtract mx from both sides, I'd have y minus mx, and that will equal b. So in order to get that, I want to figure out what the heck is mx. And then we can compute out, I've got a point where I know what y is going to be. For instance, I could take either one of these points, 63 and 156, or I could use the 74 and 213. So I know what x is, 63. I know what y is. Therefore, we also know what our m is. The last thing to solve is what's b. So here's m times x. I'm going to use my 63 inches, multiply that by the slope, and I get 326 and some change. So again, let's format that out. And then to get y minus mx and say that equals b, well, let's see, here's y, and I'm going to subtract off m times x, 326.45, and I've got my b factor, negative 170.45, which, thinking about how realistic is this and what does that number even mean? Basically, it means if somebody is 0 inches tall, they have no height, they're a negative weight. So I mean, practically the number doesn't mean all that much. But what I want to be able to do is I want to use this as a prediction. So here we're going to come up to the top. We're going to do our predicted weight and see how good our calculations are. Okay, for the predicted weight, it's going to equal the height, that's my x value, times the slope. So I'm coming down here to the slope. Where is it? There it is. And I always want to use that cell. So I'm going to hit function F4. And I want to add to it mx plus b. So we're going to add to it my calculated b value. And again, I always want to use that. Hit enter, and it's a miracle. It's 156. And that was because, well, that was one of the points right on our line. So now if I copy this down for all the rest of these, here we've got our last point. That was this one at 74 inches. Sure enough, it turned out to be exactly 213 pounds. However, we also expected this person who was 74 inches to weigh 213 pounds, but in actuality, their actual weight is 242. So now what I want to do is I want to get the difference here. So I'll call this my predicted difference. And I'll take the actual weight minus the predicted weight and copy that down for all these. And you can see some of them, we've got 2 of them that are exactly this one here and this final dot here, the ones that we used for making up our line, they're spot on. There's no difference. Some of them are negative, but some are positive. All right. And if we, again, let's just resort this, well, we'll leave it the way it is, all right? It won't hurt anything. So the fact that I'm over, or I should say under on some, over on others, that should all kind of balance out and be zero, if you will. So we're going to sum all this up and see how close we came. And we're off by a little bit. It looks as though we over predicted. I predicted 176 for this person who was 5'7", and in actuality they were 152. This one we were pretty close, 67, 176. This one again we're a little bit. We predicted more. Their actual weight was listed as this. All right, fair enough. Let's take this. Let's save this. Let's take our predicted weights, copy them. Control C. Click on my chart. Hit Control V, paste them in. There's my predicted line. I'm going to right click on this line. I want to see if I can format this data series. And let's choose the paint bucket here. We want to do a solid line. Let's make this an orange color. And rather than having a solid line here, let's try to change the dash type and maybe choose, something like that. So that way it's a little bit easier to see. There's my predicted line. And you can see the original data points. All right, so again, you could set up something like that. All this, you got to do the calculations. This is kind of doing it manually, if you will. Clearly, the easier way to do it, right-click on any one of these dots. Add a trend line. Scroll down to the bottom here. We want to set and display the equation on the chart and display the R-square value to find out how good of a fit this is. I'm going to close that up. I'm going to move this off to the side here, and let's increase my font size on it. And there we've got an equation for this line. And it puts that line right there. You can kind of see it. It's faded in there, but it's the blue line. And you can see it's a little bit below my first point. It's a little bit above where I had said. Maybe you could have picked two different points to, come up with a better prediction for ourselves, but we still managed to do it. So let's do the math and see if we can calculate this out. So we're going to call this the regression weight and the regression difference and see if they're any closer, any better. We'll see what happens. So my regression weight is going to be equal to the height times this factor here, the 7.8511, and I'm going to, in this case, subtract 356.18. So again, they generated a B of a negative 356.18. Ours was somewhat different. Hit OK, and let's format this with a comma format. So they actually predicted someone who is 63 inches is only going to weigh 138 pounds. So we can do the difference between what they actually weighed minus the regular weight, and we find out that they underpredicted compared to we were spot on. But let's copy this down, and we'll sum up all of their differences, and we find out that, well, I guess they did do a better job in terms of all these differences between the actual amount and the under amount. Notice none of those points actually lined up exactly perfect, but overall their prediction for the whole data set for our 10 records did turn out to be a little bit better than what we had come up with, just kind of ballparking it ourselves. So that's how you can do some of the manual aspect of this and take a look at it and see what happens. So let's go back to our original data set. Let's save this. and we'll select out the height and the weight. Select all, I'm sorry, let me go up to the top. Let's choose the height, hold my shift key, cursor over to weight, down arrow, and I've got all that selected. Let's go to insert, add a scatter plot. I want to move this, so let me move my smiling face down. Let's move this chart location. And, alright, let me try it again. Move the chart location. I want to move it to a different spot. We're going to say it's the height versus weight chart. It kind of crammed it all over to the right, so let's adjust our... Let's see here. We can adjust some of the scaling of this and see if we can get that data to look a little bit better. So I'm going to try to click on my scale, double click on that. Alright, let me throw my face over this way. Change the minimum. Let's see. This is the weight that I'm working on. So let's try setting that, the minimum weight, at 150 pounds, maybe? I might have to go a little bit lower than that. Here's one way I can check it. Let's hit Control Home. Let's go to the weights. Shift and down and select all those weights. And if I look here on the minimum, it looks like the minimum was 123 pounds, the maximum was 241. So let's see, I've got let's call it 120 pounds to about 250 pounds. Should be able to cover that. And if I do the same thing for the height, let's do Shift and down. And if I look on the status bar, the minimum height is 60 inches, 5 foot. And we've got 76 inches. So let's call it 80 inches, something like that. And that should help us with the scaling of our chart. So we come back here, change my scale, and let's make this 120. Tab down. Maximum turns out to be 160. You know, if you want to try the minimum, just make it 100 pounds. You know, that's not too bad. That's fitting a little bit better. And now let's try doing the same thing down here for the height. See if we can format our height. And we said we want to go from about 60 to 80. So let's try 60. And there it gave me the maximum of 78. I'm just going to put in 80. And there, our data set looks a little bit better, kind of being spread across that way. Then let's right click. Add a trend line. Scroll down. Display this equation. Give me my r squared valued. Move this off to the side so I can see it. Go to Home. Increase the font size so I can see that a little bit better. And I've got an equation of 5.9298. And my b value is a negative 221.75. So I can use that prediction. The r squared value is 0.71. So I mean, that's actually a fairly strong correlation between the two. So let's go back to our adult males. Hit Control Home and kind of ask ourselves, all right, what if we want to make a prediction? What if we have somebody who's 5 foot, 10 inches tall? So if I want to put that out in terms of how many inches is that, it equals the number of feet times 12 plus the 10 inches. So this would be my feet. Here's my inches. Here's my tote inch. And now I want to get the predicted weight. My predicted weight is going to equal 5.9298 times the inches plus my B factor negative 221.75, and we predict that this person is going to weigh 193 pounds. And we can remove the decimals and come up with that. So that's how we can do some of these predictions. Let's think a little bit about, well, what's the likelihood that, do you think we're going to be fairly close? And do some things like that. So let me save this. I'm just going to move myself back over here. And let's round off the height. And I want to round off the height. Oops, hang on. Equals round to just the nearest integer. And I can copy this down. I'm going to add another column in here just to give me some space, because I'm going to want to be able to sort this data here. I'm going to turn on my freeze panes. I want to adjust my column widths. That way, if I don't think I'm ever going to print this off, because it's going to be, I've got 700 records here. I don't need to print all that stuff off, but still, at least you want to set yourself up so you could do it. Save before I sort, and now let's try to sort this data. And let's sort this by the height. And within the height, I want to sort by the weight, in case I would happen to have any duplicates. And I'm going to page down here for the rounded heights just until I see the number 70 pop up. And I'm just hitting page down to do this. Here we go. Here's some of the heights that ended up being around 70. So we've got this one rounded up, actually, but here we go. Here's kind of the first one that was at that low point that we had. We've got some people that are 170 pounds. And let's see, what did we predict in the first place? Let me hit Control Home again. 193, all right? So remember that number, 193. Let me see if I can find my 70s. So there was one of them, 170. Go all the way down to all the 70, roughly 70s. So we've got from about 170 pounds up to 204, and our estimate of 193 kind of fits right in that range. So that kind of gives us an idea about, hey, how reasonable does this look like? The other reason why I selected those records is I'm going to go to Insert, and I'm going to open up my statistic chart and use a histogram. And when I use my histogram, you can see, really, for the most part, just about all the males fall into these three categories. Anywhere from about 181 pounds and some change up to about 200 pounds. So our prediction of 193 falls right in between that range, plus or minus, I don't know, about 7 to 9 pounds. And hence, I think that, that's what you would explain to somebody when they ask the question, well, what's the likelihood that they're going to be around 193? Well, 193, probably plus or minus 10 pounds, and you'll be about spot on as far as coming up with some good estimation. There's a few that are those outliers that kind of fall into this category. There was somebody that was 161 pounds, at the low end. Well, actually, I think it was 170 is what we computed, and then the high end was 204. Here it's carrying it out a little bit wider heavier than that, I should say. So include your histogram, and on a prediction for something like this, you can kind of test that one out. If you want to move this chart location, we can do it. And let's just call it my height, weight, histogram. And I've got that chart saved. Update the title. This was our, what do we say, 7-inch males. And maybe you just want to say 5 foot 10 inches. So 5, 10. To get an idea about what they weigh. You can change the formatting of the scales down here. You know, I mean, there we probably don't want to carry that out to 6 decimal points. You can kind of work on some of that. So let me get out of that chart. Let's see, there's my adult males. Here's my first 10 records. So for the rest of it, we've got truck prices. You know, do you really need to do the first 10 records? There's only 23 records there. You probably don't have to limit it to just the 10 records. But then again, it wouldn't hurt. You know, I mean, just start here, see if you can come up with your own prediction, and then take a look at the regression equation and calculate that out. Same thing on the cricket chirps. There's only 15 records there. You know, I'd be tempted maybe just to do an XY plot of all this data and then see if you can come up with your prediction for the number of chirps. As the temperature goes up, do the number of chirps go up? Does it hit a deadline or a maximum at some point? You can do some of those kind of predictions and see what happens there. So I hope this helps. Good luck, and get your homework done.